In this lesson, we will explore optimization in the cloud. Optimization is crucial for ensuring that cloud resources are being used effectively and efficiently. Optimization in cloud computing refers to the process of adjusting and fine-tuning various elements of cloud infrastructure to improve performance, reduce costs, and ensure high availability. Optimization involves three key components: autoscaling, right-sizing, and load balancing. First, we have autoscaling. Now, autoscaling is a process of automatically adjusting the number of computing resources based on the demand. This is achieved through the use of monitoring tools that track resource utilization and trigger the creation or removal of resources as required. For example, if the demand for the resources spikes, autoscaling will automatically add more resources to meet that demand. Conversely, if the demand decreases, resources will also be removed. Autoscaling has various benefits, such as optimizing resource consumption and cutting down on expenses. With this system, resources are dynamically generated on an as-needed basis, preventing organizations from paying for idle resources. Moreover, since resource allocation and deallocation are automated, companies don't have to handle this resource management manually, which saves time for other activities. However, setting up and configuring autoscaling requires a certain level of technical proficiency. Moreover, predicting sudden spikes in demand can be tricky, which may result in unforeseen expenditures. An example of autoscaling in cloud computing is how a social media platform like Facebook might experience a significant spike in traffic during major events or holidays. The platform uses autoscaling to ensure that there's enough capacity to meet the increased demand for resources during those periods. This allows the platform to provide a consistent level of service to its users, even during periods of high traffic, by automatically scaling upwards or outwards to continue to provide reliable services. Another important technique is called right-sizing. It means finding the perfect balance in the resource allocation for each application or service. This is done by analyzing how much of each resource is being used and adjusting it accordingly. There are several benefits to right-sizing. Firstly, it helps improve resource efficiency and lowers cloud computing costs by allocating only the necessary amount of resources. Secondly, it enhances the performance of applications and services by optimizing their resource utilization. Of course, there are always some disadvantages, and one of the disadvantages of right-sizing is that it requires a significant amount of monitoring and analysis to determine the right resource allocation for each component. The usage patterns of applications and services change, and organizations need to regularly evaluate and adjust resource allocation to ensure that these resources are being used effectively. To help you better understand it, let's take an example of a large enterprise that uses cloud-based warehousing solutions. This enterprise uses right-sizing to make sure that the resources allocated to the data warehousing solution are used in the best way possible. Now, to achieve this, the enterprise constantly monitors the resource utilization of its data warehousing components, such as the amount of CPU, memory, and storage used by each component. By analyzing how much of each resource is being used, the enterprise can allocate the right amount of resources to each component. This helps to ensure that the resources are being used effectively, which in turn improves the overall performance of the data warehouse solution. Third, we have load balancing. Load balancing is another crucial technique being used in the world of cloud computing. It involves the distribution of computing resources across multiple servers to optimize resource utilization. Now, this can be done by using load balancing algorithms or tools. Load balancing has several advantages, including enhancing resource utilization and reducing downtime. By distributing resources across multiple servers, organizations can ensure that they are being used in the best way possible. Furthermore, if one server fails, distributing resources across multiple servers can help to ensure that the application and service remains available. One disadvantage of load balancing is that it requires a significant amount of technical expertise to set up and configure. Additionally, load balancing algorithms and tools can be complex, which makes it challenging to understand and diagnose issues. Plus, if you're using load balancing across multiple servers, you are now also paying for multiple servers. For this reason, it is important to use load balancing with autoscaling and right-sizing to ensure that you're always providing the right number of servers behind your load balancer to meet your performance requirements, while at the same time minimizing the number of servers to only what is required so that you don't create a larger cloud computing cost for your organization. Now, a real-world example of load balancing is streaming services. For instance, a streaming service may use load balancing to manage the distribution of its content to its users. The service can use a load balancing tool or algorithm to distribute the incoming traffic across different servers, ensuring that each server is used optimally and no server is overloaded. By using load balancing, the streaming service can handle a large amount of users who may be streaming content simultaneously without experiencing any issues such as buffering or crashes. Load balancing ensures that the service remains available and performs well, even during times of high traffic. This helps to ensure that users have a seamless and enjoyable streaming experience. So again, optimization is an important aspect of ensuring the smooth and efficient functioning of a cloud-based system. Also remember that there are 3 key techniques for optimizing cloud computing, which are auto-scaling, right-sizing, and load balancing. Auto-scaling helps organizations to automatically allocate resources based on demand, ensuring that resources are not wasted and that the system remains available even during periods of high demand. Right-sizing helps organizations choose the appropriate size of their cloud instances, ensuring that they are not overpaying for more resources than they actually need. Load balancing helps organizations to distribute incoming traffic across multiple resources, ensuring that the system remains available and that the performance of the system is not impacted by the spikes in incoming traffic. Each of these techniques has its own advantages and disadvantages, but when used correctly, they can help organizations to optimize their cloud computing environments and to ensure that they are running as efficient and cost-effective as possible. Whether an organization is just starting to adopt cloud computing or has been using it for years, it's important to regularly assess and optimize the cloud computing environment to ensure that they are getting the most value from the cloud investment.